You begin by floating, not falling, through a darkness that does not feel empty. It feels soft, like deep night behind closed eyes. Space here is wide and calm, and you move through it as if carried by a slow breath. There are no sharp edges, no sudden sounds, only a vast, cool hush that stretches in every direction. Around you drift enormous clouds, but they are not like the clouds you know. They are not made of water droplets or stormlight. These are interstellar clouds, long rivers of gas and dust, spread across distances so large that even light needs years to cross them. They are thin, almost impossibly thin, yet gathered in such enormous volume that they become the birthplaces of suns. You can imagine them like cosmic fog banks, made mostly of hydrogen, the simplest and most ancient element. Hydrogen, just one proton, one electron, humble and abundant. It is the universe's favorite building block. You are surrounded by it now, though it is so sparse you would not feel it on your skin. Still, it is here. Waiting. Your movement slows as you enter one of these regions, a molecular cloud, cold and dense by cosmic standards. The temperature is low enough that atoms can hold hands and become molecules. Tiny grains of dust drift between them, flecks of carbon and silicon, like powdered stone from ancient stellar lives. You are inside a place where stars are possible, but not yet awake. Nothing shines here. Nothing burns. And yet, everything you see is preparing for fire. Gravity is present, though you cannot see it. It has no color, no sound, no scent. But you can feel its intention, a gentle inward tug, like the pull of sleep. Every particle in the cloud attracts every other particle. The force is weak when measured between two atoms, but there are not just two. There are trillions upon trillions upon trillions. Added together, their tiny attractions become a quiet command, come closer. You watch as slightly denser regions begin to thicken more. Not everywhere, only in certain pockets, like folds in fabric. A ripple passes through the cloud long ago, perhaps from a distant stellar explosion, perhaps from a galactic spiral arm's slow squeeze, and that ripple left behind unevenness. And unevenness is enough. Gravity favors imbalance. Where there is a little more matter, there is a little more pull. Where there is more pull, more matter gathers. You hover near one of these knots of growing density. It does not look dramatic. If you expected fireworks, you smile gently at the misunderstanding. The universe does not rush its masterpieces. The gathering is gradual, like snow collecting in a quiet field. Atoms drift inward. Collisions occur, soft, invisible taps. Each meeting trades a whisper of energy. Motion slowly randomizes, then settles. The region grows denser still. Gravity tightens its embrace, not as a snap, but as a promise. You notice something comforting. Collapse in space is not like collapse on Earth. It is not a crash. It is more like leaning. A long, continuous leaning inward. As the gas gathers, something subtle changes. Movement turns into warmth. When particles fall inward, they convert gravitational energy into heat, just as your hands warm when you rub them together. Temperature begins to rise in the center of the knot. Still cold by earthly standards, but warmer than before. A gradient is born, a difference between outer cool and inner less cool. Differences are the engines of all natural stories. You drift closer and sense rotation. The cloud is not perfectly still. Nothing in the universe ever is. Even a slight spin, present at the beginning, becomes stronger as the region contracts, like a figure skater drawing in their arms. The forming core rotates faster. A flattened disk begins to appear around it, subtle and wide. Structure emerges from softness. You are witnessing the earliest stage of a protostar, not yet a star, but a star in the making. It is like an idea before it becomes a word. Dust within the disk bumps and sticks, building larger grains, then pebbles, then seeds of future worlds. You do not rush ahead to planets yet, you simply notice that creation likes to work in parallel. While the center prepares for light, the edges prepare for form. The inward fall continues. Density increases. Pressure rises. Temperature climbs. You imagine layers piling gently atop layers, like blankets. With each added layer, the center feels more weight above it. Pressure is simply weight that cannot spread sideways. It must go somewhere, so it goes inward. You rest in the rhythm of it, gather, warm, compress. Gather, warm, compress. Time passes differently here. Thousands of years feel like moments. 1,000,000 years feels like an afternoon. You are not counting, you are listening. The cloud is composing something slow and patient. At the center, the forming protostar grows opaque. Light created by collisions cannot travel far before meeting another particle. Energy becomes trapped, bouncing from atom to atom like a message passed through many hands. This trapped energy raises the temperature further. The core becomes a hidden lantern, not yet lit, but close. You might expect a clear boundary, a line where not star becomes star. But nature rarely draws hard borders. Instead, there is transition. A deepening. A nearing. You place your attention at the core and imagine pressure increasing to extraordinary levels. Atoms are squeezed closer than they have ever been. Electrons remain loyal, but crowded. Motion grows frantic. Heat builds not from flame, but from falling. There is still no nuclear fusion yet, not quite. Hydrogen nuclei are not merging. The threshold has not been crossed. But you can feel how near it is. Like dawn before the first color. Around you, the remaining cloud continues to drift, feeding the center. Not all of it will join. Some will be blown away later by newborn radiation and stellar wind. But for now, the infall continues, steady as breathing. You realize something gentle and profound. Stars are not born from violence first. They are born from patience. From accumulation. From the willingness of matter to come together. The universe does not only explode things into existence, it also gathers them into being. You float there, suspended in the quiet, watching gravity write its slow signature. You feel no urgency. No countdown. Only approach. The core grows hotter. Denser. Brighter, though the brightness is still hidden inside its cocoon. Conditions are approaching a sacred threshold, the moment when pressure and temperature become great enough for hydrogen nuclei to overcome their natural electrical repulsion and fuse. When that happens, a new kind of energy will awaken, not from falling, but from transformation. You sense that you are on the edge of ignition. And as the warmth deepens and the center tightens, you remain still, knowing that in the next quiet moment, the first true stellar heartbeat will begin. You remain near the hidden core you sensed before, and without any sudden flash or sharp sound, the change arrives. It is not an explosion. It is not a spark. It is more like a lock softly turning. Pressure and temperature reach their patient agreement, and the first sustained fusion begins. You do not see it directly, but you understand what is happening. Deep in the center, hydrogen nuclei, simple protons, are pressed so close together that their natural repulsion is overcome. They merge. When they join, they form helium, and in that joining, a small portion of mass becomes energy. Not metaphorically, literally. Matter relaxes into light. You can imagine it like snowflakes pressed into a crystal of ice, releasing hidden warmth as they settle into a tighter pattern. The star has found a new way to stand up against gravity. No longer only falling inward and heating, now it is generating energy from within. This is the moment a true star begins its long middle life. You notice how calm it feels. After the long gathering and deepening, this phase is steady and reassuring. Energy flows outward from the core in all directions. It travels slowly at first, bouncing from particle to particle, taking thousands of years to reach the surface. The journey of each photon is not a straight line but a wandering path, like a traveler moving through a dense forest. Gravity still pulls inward with unwavering loyalty. It has not weakened. But now there is a response, outward pressure created by heat and radiation. The two forces meet and hold each other in perfect tension. The star becomes a balanced conversation between inward and outward, between compression and release. You drift just above the surface and sense the glow. Not harsh, not burning, just steady. The star shines because its interior is busy, because countless fusion reactions occur each second, each one a tiny note in a vast, continuous chord. You think of the core as a heart, but not a beating one. It is more like a deep humming engine of transformation. Every second, enormous numbers of hydrogen nuclei fuse. Yet the star is so large that this furious activity appears peaceful from the outside. Power, when spread across immensity, becomes serenity. You feel warmth traveling outward in waves. First through radiation, light carrying energy, then nearer the surface through convection, where hot material rises and cooler material sinks, like slow cosmic weather. Columns of plasma circulate in grand loops. The surface is not solid, it is a restless ocean of charged particles. If you listen with imagination, the star has a sound, a low, endless chord. Vibrations ripple through it. Pressure waves bounce inside like echoes in a cathedral. Astronomers call this stellar oscillation, but you think of it as breathing. Expansion, slight contraction, expansion again. A rhythm too subtle for eyes, but real. You realize something comforting. Most stars spend the majority of their existence in this stable phase. This is not a brief performance, it is the long, glowing middle chapter. For millions to billions of years, depending on mass, the star will simply shine. Mass, you learn, is destiny here. A heavier star lives faster and brighter, spending its fuel with generous speed. A smaller star sips slowly and can glow far longer. Size sets the tempo. The universe allows different lifespans, but the same rules. You imagine the core as a careful accountant. There is a fuel supply, hydrogen, and a burn rate determined by pressure and gravity. The greater the inward squeeze, the faster fusion must run to resist collapse. So the most massive stars are the most brilliant and the most brief. Intensity trades itself for time. You move closer again, not physically, but with attention. Fusion in this stage follows a chain of steps, protons merging through a sequence of transformations, sometimes briefly becoming other particles, releasing neutrinos and gamma rays, until helium is formed. It is intricate, but you do not need the equations. You hold the feeling, simple beginnings, structured joining, radiant outcome. Energy created in the core begins a long outward migration. A photon may be absorbed and re-emitted countless times, changing direction with every interaction. Its path is random, patient, indirect. What leaves the surface today may have begun its journey long before mountains formed on your world. This thought slows you pleasantly. Light itself practices patience. At the surface, energy finally escapes freely into space. The star shines across the dark like a lantern placed in an endless field. Light travels outward at full speed now, no longer delayed by dense matter. Warmth and illumination spread in expanding spheres. Around the star, leftover material from the birth cloud continues to orbit dust, ice, rock grains. The steady radiation and particle wind begin shaping this environment. Lighter gases are pushed outward. Magnetic fields twist and guide charged particles. The neighborhood becomes organized by presence alone. You notice that stability is not stillness. The star is active, dynamic, constantly transforming mass into energy. Yet because the forces are balanced, the activity feels calm. Like a spinning top that appears motionless when perfectly centered. You rest in that idea. Balance is not the absence of motion, it is motion arranged so well that it becomes peace. Time flows. Fusion continues. Helium ash slowly accumulates in the core, the byproduct of hydrogen burning. It settles inward because it is slightly heavier per particle. The core's composition changes grain by grain. Nothing dramatic yet. Just a gradual shift, like sand gathering at the bottom of a glass. The star does not notice in any conscious way. It simply continues its work. But you, watching gently, understand that this quiet accumulation matters. The story is progressing even during calm chapters. You sense how dependable this phase is. If a star had a personality here, it would be centered, generous, unwavering. It gives more energy each second than worlds can measure, and asks nothing in return. It shines because that is what its structure allows. You let your awareness widen and imagine many stars in this same stage, scattered through a galaxy like warm windows in a distant city at night. Each one holds a core of fusion, a shell of glowing plasma, a long agreement between gravity and light. The universe, you realize, is not mostly explosions. It is mostly maintenance. Long eras of steady shining, of balanced forces holding shape against collapse. You float in the comfort of that maintenance. Predictable does not mean boring. Predictable means trustworthy. But deep inside, helium continues to gather. Hydrogen in the very center slowly decreases. Fusion still thrives in a broad central region, yet the exact middle is changing character. The fuel mix is not what it once was. The balance will someday need to adjust. Not today. Not soon. But inevitably. You feel the faintest hint of future movement, like a distant shift in musical key. The star remains bright and composed, but you now understand that even stability contains direction. Even calm has a destination. You rest beside the warm glow, knowing that the quiet tug between gravity and fire never truly stops negotiating, and that their conversation will shape everything that comes next. You remain near the living star, wrapped in its steady warmth, and now you begin to notice something more subtle than light. Beneath the glow, beneath the flowing energy, there is a relationship, a quiet tug between two great tendencies of nature. One always pulls inward. One always pushes outward. You can think of gravity as the great gatherer. It never sleeps, never gets distracted, never changes its mind. Every particle with mass invites every other particle closer. No announcements, no commands, just attraction. A continuous inward leaning written into the fabric of existence. Inside the star, gravity is immense. All that mass, more than you can comfortably imagine, presses toward the center from every direction at once. It is like an endless, spherical snowfall, where every flake falls toward the same middle point. If gravity were alone, the star would continue collapsing, shrinking, tightening, heating, with no pause. But gravity is not alone here. From the core flows energy born from fusion, hydrogen becoming helium, mass becoming radiance. This energy does not sit still. It moves outward, carrying momentum, heat, and pressure. You can imagine it like a rising tide of light, pushing gently but persistently against the inward squeeze. This outward influence is called pressure, but you feel it more like a response. Gravity asks everything to come closer. Fusion answers, not so fast. You picture two hands meeting, not fighting, not striking, simply pressing against each other with equal strength. The star lives in that contact point. You drift through a layer where energy is passing outward through radiation. Photons scatter, bounce, and redirect, transferring their push to the surrounding plasma. Each interaction is tiny, but together they create a cushion, a distributed outward support that holds the upper layers up. Without it, the weight above would fall freely. Balance, you realize, is not passive. It is continuously maintained. If fusion slows even slightly in the core, gravity notices immediately. The inward squeeze increases. Compression raises temperature and pressure, which then speeds fusion again. And if fusion runs a little too strongly, outward pressure increases, the core expands slightly, and reactions slow. The system self-adjusts, like breathing. You find this deeply calming, a built-in feedback loop written into nature. Not control from outside, but regulation from within. You imagine lying between two steady ocean waves meeting from opposite directions. You are not crushed because their strengths match. The meeting creates stillness, but it is a stillness made from motion. The star's shape, round, full, luminous, is simply the visible result of this invisible agreement. You turn your attention again toward the center. Conditions there are extreme beyond ordinary language. Temperatures of millions of degrees. Pressures so high that matter behaves more like a collective than individuals. Yet the principle remains simple: inward pull, outward push. Complexity built from two opposing verbs. You appreciate how this mirrors other parts of existence. Your own breathing, inhale, exhale. Your heartbeat, contract, release. Even walking is a managed fall repeatedly caught. Stability is often a dance, not a statue. The star is not frozen in perfection. It is dynamically balanced, always adjusting, always recalculating without thought. You could call it hydrostatic equilibrium, but the phrase feels too stiff for what you're witnessing. You prefer to think of it as a truce renewed every moment. You wander outward toward the star's midlayers, where energy transport changes character. Here, hot plasma rises while cooler plasma sinks, forming convection currents. Vast columns circulate slowly, like lava lamps the size of worlds. Rising material carries heat upward physically now, not just through light alone. Each rising plume adds to outward support. Each sinking stream removes cooled material from above. The circulation is not chaotic, it is organized turbulence, purposeful motion. You notice that even disorder can serve balance. The surface flickers and shifts. Bright cells form and fade. Magnetic fields loop and snap, guiding charged particles along invisible lines. The star is alive with motion, yet its overall size and brightness remain remarkably steady across long spans of time. Consistency, you learn, does not require stillness, only proportion. You imagine what would happen if gravity suddenly strengthened. The core would compress. Temperature would spike. Fusion would accelerate. Outward pressure would grow until a new balance point was found. The star would adapt. And if gravity weakened, the opposite would occur. Expansion. Cooling. Slower fusion. A gentle settling into a different equilibrium. The star is not rigid, it is responsive. This responsiveness feels almost biological, though it is purely physical. No intention, only law. No desire, only consequence. You rest in that thought that reliable behavior can emerge without awareness. That order does not always need a planner. Sometimes it only needs rules that never break. Time continues to pass in long, smooth stretches. Hydrogen continues fusing. Helium continues accumulating in the core like fine ash after a long burn. The balance still holds, but the ingredients are slowly shifting. You cannot see the difference from the outside glow, but you know it is happening. The inward pull depends on total mass that stays nearly the same. The outward push depends on fuel and reaction rate that will not stay the same forever. Even a perfect tug-of-war changes when one side slowly trades rope for stone. You do not feel alarm at this. Only curiosity. Change here is not sudden, it is gradual enough to be gentle. The star will not lose balance in a moment, but across ages. You float again near the core and sense the pressure, the brightness, the resistance. Gravity continues its endless invitation inward. Fusion continues its radiant reply outward. Between them, structure exists. Light exists. Warmth exists. You realize that what you are truly witnessing is negotiation, not conflict, but conversation. Two universal tendencies answering each other across time. And as the helium fraction grows quietly at the center, and the equations of balance prepare for their next adjustment, you feel that this peaceful tension is leading somewhere toward a slow turning point not yet visible, but already written in the star's deepening heart. You remain beside the steady star, wrapped in its warm, dependable glow, and for a long while nothing seems different. Light continues to pour outward. Energy continues its patient journey from core to surface. The balance between gravity and fusion still holds like two hands pressed evenly together. If you only glance, you would say everything is the same. But you are not only glancing now. You are listening more closely. Deep in the core, where fusion has been quietly turning hydrogen into helium across vast ages, the mixture is no longer what it once was. The supply of hydrogen in the very center, the most pressured, most active region, has been thinning grain by grain. Not gone. Not suddenly absent. Just less abundant than before. You imagine a long burning candle. From across the room, it looks unchanged for hours. Only when you sit near it do you notice the wax reshaping, the wick shortening, the flame adjusting its posture. So it is with the star. Its flame still shines, but its inner proportions are shifting. Helium, the ash of hydrogen fusion, has been collecting in the core. It does not burn under the current conditions. It waits. It is heavier per particle and settles inward, forming a growing center of spent fuel. Around it, in a surrounding shell, hydrogen fusion still continues, a bright layer wrapped around a quiet heart of helium. This is a gentle rearrangement, but an important one. You move inward with your awareness and sense the difference. The very center is no longer the busiest place. Fusion has migrated slightly outward into a shell where hydrogen remains plentiful. The core itself is becoming denser, because without active fusion there, less outward pressure is generated locally. Gravity notices immediately. Gravity always notices. With less fusion support at the exact center, inward pull tightens its hold. The helium core begins to contract slowly. Not collapsing, not rushing, simply compressing, like a pillow gradually pressed by increasing weight. Compression raises temperature, even without new fusion. Falling inward always warms matter. Motion becomes heat. You feel the paradox. As fuel fades in one sense, temperature rises in another. The contracting core warms the surrounding shell, and that added heat makes the shell's hydrogen fusion run faster. More reactions per second. More energy produced in that layer. The star responds as a whole to this internal shift. From the outside, the change first appears as a slight brightening. A subtle increase in total energy output. The star is adjusting its structure to maintain balance, and the adjustment has visible consequences. Equilibrium is preserved, but differently than before. You realize that balance is not a fixed position. It is a moving target. The outer layers feel the increased energy flow from below. With more outward pressure passing through them, they expand slightly. Expansion cools them a little, the way air cools when it spreads. The surface temperature dips even as total brightness grows. Color can shift gently toward the redder side of the spectrum. No alarms ring. No boundaries are crossed sharply. The star simply evolves, like a voice changing with age. Inside, nuclear reactions become more varied. In regions hot enough, helium nuclei occasionally collide and briefly form heavier elements in tiny amounts, though sustained helium fusion has not yet begun. These are like preview notes, hints of a deeper movement still to come. You think of the core as a changing orchestra. The high, quick notes of hydrogen fusion are no longer dominant at the center. Lower, heavier tones are gathering, waiting for the right conditions to sound fully. Composition follows compression. Time continues to move in million-year steps. You practice feeling time this way: wide, unhurried, generous. There is no need to rush a star through its chapters. Each phase deserves its full breath. The contracting helium core grows hotter and denser. Pressure increases to extraordinary levels. Electrons are squeezed closer to atomic nuclei, forming a state of matter that behaves differently, more rigid in its resistance to compression. Quantum rules begin to matter more here, adding a new kind of pressure born not from temperature, but from the nature of particles themselves. You don't name it with technical language. You simply feel it as a new firmness deep inside, a crowding that pushes back. Above this firming core, the hydrogen-burning shell continues energetically. Because it sits slightly farther from the center, it occupies a larger volume than the old central fusion region did. More space can participate. The outer envelope of the star responds by expanding more noticeably now. You watch the star slowly swell. Its radius grows. Its surface stretches outward into space. If it had nearby planets, their skies would be growing brighter and hotter with each passing age. Distance would matter more each century. Expansion is not explosion. It is more like a long exhale. As the surface spreads, its heat is distributed across a larger area. Temperature per unit surface drops. The glow becomes softer in color, even as total light increases. The star is beginning its approach toward a giant phase, though it has not fully arrived there yet. You sense a tenderness in this stage. The star is not failing, it is transitioning. Its structure is reorganizing around new internal truths. Old fuel patterns no longer fit, new ones are preparing to take their place. You reflect that many systems change this way. First subtly at the center. Then gradually in outer expression. Inner chemistry writes outer appearance. The idea feels personal, and that is allowed. Science does not lose meaning when it becomes intimate. You drift along the expanding outer layers and feel convection growing stronger. Rising and falling currents travel longer distances now. The circulation patterns widen, like weather cells on a warming world. Magnetic fields twist in broader loops. The surface grows more textured, more dynamic. Yet still, from far away, the star looks peaceful. A calm point of light. No distant observer would guess the intricate restructuring underway within. Transformation often hides behind familiar brightness. You return your attention to the deep core one more time. The helium center continues its slow contraction. Temperature climbs toward a future threshold, the point where helium itself will begin to fuse into heavier elements like carbon and oxygen. That ignition requires more heat than hydrogen ever did. The star is not ready yet, but it is preparing. Preparation, you realize, is an active phase of nature, not an empty wait. Nothing here is wasted motion. Every compression, every reaction, every outward adjustment is part of a longer arc. The star is aging, yes, but aging in physics means unlocking new possibilities, not simply declining. You rest in that reassurance. The glow around you remains warm and steady, but you now understand that steadiness can contain direction. Deep inside, the fuel story is changing chapters. The center grows heavier. The shell burns brighter. The surface stretches outward in response. And as you float in the softened light of this subtly evolving star, you can feel that expansion is not the ending, it is the doorway to a far more dramatic transformation still waiting to unfold. You remain near the star as its long middle age gives way to something more spacious, more dramatic, yet still unhurried. Change continues not as a sudden event, but as a deepening trend. The inner rearrangements you sensed before are now shaping the whole star. What was once subtle is becoming visible. The outer layers continue their slow expansion. Not a burst, not a shock, but a steady outward drifting, like fabric being gently stretched by invisible hands. The star is growing into a giant. You watch its surface move farther from the core, layer by layer. If you could place markers in space, you would see each one gradually overtaken by the swelling edge. Distances that once held empty darkness are now filled with glowing plasma. The star occupies more of the night. Inside, the helium core keeps contracting under gravity's constant persuasion. Without active fusion at its center, not yet, it cannot generate enough outward pressure of its own. So it tightens. And as it tightens, it heats. Falling inward is another way of lighting a fire, though this one is still contained. Around that tightening core, the hydrogen-burning shell grows more intense. You can picture it like a bright ring of flame wrapped around a dark, heavy seed. Because the shell sits at a slightly larger radius than the old central fusion zone, it contains more material. More fuel can burn at once. Energy output increases. More energy rising from below means more support pushing upward through the star's envelope. The outer layers respond the only way gases can when pressure increases beneath them, they expand. You drift through these outer regions and feel how different they are becoming. Density drops. Material spreads out. Particles that were once closer neighbors now travel longer distances between collisions. The star is becoming more diffuse near its surface, more cloud-like, even as it grows brighter overall. There is a softness to a giant star's outer atmosphere, a looseness like foam compared to stone. As expansion continues, surface temperature falls. This may seem surprising at first, so you sit with it gently. The same total energy is now radiating from a much larger area. Spread warmth across a wider field, and each part feels cooler. The color of the glow shifts toward deeper orange and red tones. Cooler light, but more of it. You imagine dipping a brush into warm paint and pulling it outward across a canvas. The color thins, spreads, and changes character without disappearing. The star now belongs to a new category of being a red giant in the making. Its personality has changed. Where once it was compact and steady, it is now vast and breathing, its outer layers rising and falling in slow, grand currents. Convection cells grow enormous, each one possibly larger than entire planets. Hot plasma rises, cools, and sinks again in cycles that can last months or years. You float within one of these currents and let it carry you upward. Motion here is not violent, it is stately. A royal stirring rather than a storm. With expansion comes another quiet consequence: gravity at the surface weakens. Not gravity overall, the star's total mass is nearly the same, but surface grip decreases because you are farther from the center. Escape becomes easier. The outermost particles are held more loosely now. A gentle stellar wind begins to strengthen, a continuous outward stream of particles flowing into space. Not a blast, but a leak. The giant is beginning, very slowly, to shed itself. You find this strangely tender. Even in growth, there is letting go. Deep below, the helium core grows denser still. Pressure climbs to extraordinary values. The particles are packed so tightly that new forms of resistance appear, pressure arising from quantum rules, from the fact that certain particles refuse to share identical states. Matter pushes back simply because of what it is allowed to be. You do not name the rule. You just feel its effect, a hidden firmness, like a floor beneath compression. Temperature in the core approaches a critical future threshold. Helium fusion requires far more heat than hydrogen fusion did. The star is climbing toward that requirement step by step, powered by gravitational contraction. It is like winding a spring tighter, storing potential for a different kind of fire. Above the core, the hydrogen shell burns brighter still, adding to the outward push. The envelope responds with further swelling. The star may now be tens or even hundreds of times its earlier radius. If placed where a smaller, younger star once stood, it would engulf the inner orbits of nearby worlds. You pause with that image, not as catastrophe, but as scale. Growth in one context can be overwhelming in another. Perspective defines drama. The surface flickers with slow brightness variations. Giant stars often pulse, expanding slightly, then settling, then expanding again as internal energy flow and gravity continue their negotiation in this new regime. These are not heartbeats but long breaths. You match your awareness to that breathing. Outward. Inward. Outward again. Chemistry in the outer layers becomes more complex as convection dredges up material from deeper zones. Elements forged earlier in the star's life are mixed upward. The surface composition tells a story now, a visible record of inner processes. The giant wears hints of its history in its glowing skin. You appreciate that nothing here is wasted. Each phase prepares the conditions for the next. Hydrogen burning built helium. Helium contraction prepares helium burning. Each chapter writes the opening paragraph of the one that follows. The star is no longer in quiet adulthood. It is in late maturity, magnificent, expanded, slightly unstable, yet still luminous and purposeful. Its light is softer in color, richer in volume. It feels less like a steady lamp and more like a great floating ember. You drift far enough away to see it whole. The size is breathtaking now. What once looked like a precise point has become a broad sphere of glowing atmosphere. Space around it feels smaller by comparison. Presence has weight. And yet, for all its grandeur, you sense vulnerability too. The structure depends on layered burning, shell outside core, pressure outside gravity, heat outside collapse. More moving parts mean more ways to change. Complexity carries both beauty and fragility. You let that idea settle without worry. Fragility is not failure. It is simply sensitivity to the next turning. Inside, the core temperature continues its steady climb. Closer now to the ignition point where helium nuclei will finally begin to fuse into carbon. That future fire will not be as gentle as the hydrogen one. It will arrive under more extreme conditions, with different rules, different consequences. But not yet. For now, the giant continues to expand, to glow, to breathe out light across space. Its outer layers drift like illuminated mist. Its inner heart tightens like a drawn bowstring. Expansion above, compression below, a mirrored motion. You rest between those two directions and feel the tension becoming more pronounced, more meaningful. The star is growing larger, yes, but also moving closer to a moment when growth will no longer be enough to maintain balance. And as you float in the wide red glow, watching the envelope slowly billow outward while the hidden core gathers heat and pressure and silence, you begin to sense that the next change will not be just expansion, it will be ignition of a deeper fire, or the beginning of a fall. You leave the wide, glowing envelope of the giant star and move inward again, gently, as if descending through layers of warm, luminous fog. The outer regions still breathe in slow convection, rising and falling in grand currents, but your attention now settles on the core, the hidden engine room where the next turning point is being prepared. The helium core that once only contracted is no longer quiet. Its temperature has climbed high enough for a new kind of fusion to begin. Helium nuclei, each made of 2 protons and 2 neutrons, are now able to collide and join under the crushing pressure. When 3 of them merge through a delicate sequence, they form carbon. With further reactions, oxygen can appear as well. A deeper fire has ignited. You imagine this not as a sudden blaze, but as a change in musical register. Hydrogen fusion was a bright, high melody. Helium fusion is lower, richer, more complex. It requires more heat to begin and gives different products in return. The star is now composing with heavier notes. For a time, this new fusion provides fresh outward pressure in the core. Gravity's inward pull is answered again, and a renewed balance forms, but it is more temporary than before. Helium fuel is less abundant than hydrogen was. The reactions are more sensitive to temperature. The margin for stability is narrower. You sense this narrowing like a path becoming steeper. As helium burns into carbon and oxygen, another layer of ash forms at the center, heavier, denser, more tightly packed. Around it, if conditions allow, helium fusion may continue in a shell, while hydrogen fusion still burns in an outer shell beyond that. The star becomes layered like an onion of fire, different fuels burning at different depths. Each layer contributes some outward support. Each layer also represents fuel that will not last forever. You move closer to the very center and feel how extreme the conditions have become. Density has climbed to astonishing levels. Matter here is no longer arranged like ordinary gas. Particles are crowded so tightly that their quantum properties dominate behavior. Pressure does not come only from heat now, but from the refusal of certain particles to occupy the same state. It is a strange, invisible stiffness, a rule of nature acting like an unseen pillar. For a while, that pillar helps hold the core up. But fusion continues its progression. In more massive stars, the kind destined for black hole endings, temperatures can rise enough after helium burning for carbon itself to fuse. Then neon. Then oxygen. Then silicon. Each stage happens faster than the one before. What took millions of years at the hydrogen stage may take thousands, then years, then days. You feel the acceleration not as panic, but as quickening tempo. The rhythm of change is speeding up. Each new fusion stage produces heavier elements and releases energy, but with diminishing return. The energy gained per reaction decreases as nuclei grow more tightly bound. It is like squeezing water from drier and drier soil. More effort, less yield. Still, gravity never reduces its demand. The core grows hotter with each contraction between fusion stages. When one fuel type is exhausted at the center, fusion pauses there, and gravity tightens its grip again, compressing the ash until the next fuel ignites if the temperature threshold can be reached. Burn, exhaust, contract, ignite. A repeating pattern, each cycle shorter and more intense. You sit with this pattern and let it feel familiar. Effort, output, depletion, regrouping. Even stars work in phases. Eventually, silicon fusion begins in the most massive cores. Silicon nuclei combine through complex chains to form iron group elements, especially iron and nickel. This stage is brief and fierce, like the last bright flare of a lamp running low. It can last mere days. Compared to the star's long earlier life, it is a final sprint. And when iron accumulates at the center, something fundamentally changes. You approach this iron core with special quiet. Iron is different. Not emotionally, physically. Its nucleus is among the most tightly bound arrangements of protons and neutrons. Fusing iron into heavier elements does not release energy, it consumes it. It is no longer a fuel. It is an energy cost. You picture a machine that has always powered itself by rearranging parts, and suddenly the remaining parts require power instead of providing it. The engine cannot run forward using that material. The chain of supportive fusion reactions reaches its limit here. The core becomes a growing sphere of iron ash, surrounded by shells still burning lighter fuels above. Those shells continue briefly, but they cannot support the very center directly. The center has lost its internal power source. Gravity feels this immediately. Without energy-producing fusion at the core, there is no longer enough outward pressure generated there to resist inward pull. The quantum-based pressure from crowded particles still helps, but mass keeps increasing as surrounding shells deposit more iron ash inward. Weight grows. Demand grows. Support does not. You sense the structure becoming precarious. Not visibly, not yet, but mathematically, physically, inevitably. There is a limit to how much mass this iron core can support through particle resistance alone. Add enough weight, and even that hidden pillar will fail. The temperature is enormous. The density is staggering. And yet, paradoxically, the core is closer to collapse than to explosion. No more profitable fusion remains available to rescue it. The ladder of nuclear energy has reached its final rung. You let the idea arrive softly. There exists a kind of matter that cannot help you stand up. Around the core, fusion shells flicker in stacked layers: silicon, oxygen, neon, carbon, helium, hydrogen, like nested lamps. From a distance, the star still shines tremendously. The outer envelope still glows red and vast. No distant observer would guess that the center is approaching structural surrender. Outer brightness can hide inner exhaustion. Neutrinos, nearly massless particles born in huge numbers during late fusion reactions, begin to stream out freely, carrying energy away without interacting much with the star. It is like heat escaping through invisible cracks. Cooling where you most need warmth. Loss where you most need support. You feel the imbalance widening. The iron core grows toward its critical mass, the threshold beyond which it cannot remain stable under its own gravity. The exact value depends on details, but the principle is simple: too much weight above, not enough pressure within. The phrase comes to you gently, the core cannot hold. There is no drama yet. No motion you can see. Only a tightening of conditions, a narrowing of options. A tall tower built of successful reactions now stands on a foundation that cannot grow stronger, only heavier. You rest in this moment before the fall, not fearful, but attentive. Nature often pauses at thresholds. Not because it hesitates, but because transitions occupy real time. Even inevitability has a duration. Deep in the star's heart, equations are tipping. Support curves are flattening. Gravity is preparing to move without opposition. And you remain still beside the silent iron center, feeling that the next change will not be another ignition, but something far more sudden, a downward rush that begins when resistance finally runs out. You remain beside the iron core, in the quiet moment where support has thinned to almost nothing. For a long while, everything has been negotiation, pressure answering gravity, fusion answering compression, heat answering weight. But now the conversation is ending. One voice is fading. The core has reached its limit. There comes a point, precise, physical, unavoidable, when the inward pull of gravity becomes stronger than every available form of resistance inside the iron center. Thermal pressure is no longer enough. Particle-based pressure has reached its ceiling. No new fusion reaction can start to help. The structure has run out of arguments. Collapse begins not with noise, but with surrender. At first, it is almost impossible to notice. A slight inward acceleration. A subtle increase in compression rate. But gravity is a force that compounds. As the core shrinks, its surface moves closer to its center. Closer distance means stronger pull. Stronger pull means faster shrinking. Faster shrinking means even stronger pull still. A loop forms, tightening, feeding itself. You feel the tempo change from slow breathing to sudden falling. What took thousands of years now takes seconds. The core contracts catastrophically, a word that sounds emotional, but here simply means structurally unstoppable. Atoms are pushed together with such force that their familiar structure cannot survive. Electrons, once orbiting nuclei in spacious probability clouds, are driven inward. Pressure becomes so extreme that electrons merge with protons, forming neutrons and releasing floods of neutrinos. Identity changes under compression. You imagine a library where all the books are pressed so tightly that the pages lose their gaps and become a single block of paper. Distinctions blur. Structure simplifies under force. The inner core becomes neutron-rich matter, incredibly dense, incredibly compact. A teaspoon of this material, if you could hold it, would outweigh mountains. Density here is no longer an abstract number. It is a condition of existence. The collapse accelerates toward a fraction of the speed of light. In less than a second, the iron core, once larger than a planet, shrinks to a sphere only tens of kilometers across. A city-sized remnant formed from a stellar heart. You stay present with the speed of it. Not frantic, just fast. Like a trapdoor opening beneath matter itself. Neutrinos stream outward in unimaginable numbers, carrying away energy and lepton balance. They pass through the star's outer layers almost without interaction, like ghosts through fog. For a brief moment, the star is brighter in neutrinos than in light, though no, I could see it. The inner region overshoots equilibrium and rebounds slightly. Neutron matter resists further compression strongly once packed this tightly. The inward fall slams into this new resistance and produces a shock wave, a compression ripple moving outward from the rebounding core boundary. You picture a ball dropped onto a hard floor. It compresses, then pushes back. Only here, the ball is a star's center, and the floor is quantum matter. The outward moving shock begins with great promise, but it faces a difficult journey. Above it still lies the massive outer core layers of heavy elements that are themselves falling inward. The shock must push against this infalling material. It loses energy as it goes, like a wave climbing a steep beach. For a moment, a delicate, dangerous moment, it seems the shock may stall. But the neutrinos you sensed earlier are not finished with their role. A fraction of them deposit energy into the surrounding layers, reheating and re-energizing the shock region. This added push helps revive the outward surge. Energy transfer through particles that rarely interact becomes decisive. You appreciate the subtlety. Even nearly invisible actors can shape the largest events. The collapse phase, the inward rush, is already complete. What follows next will be outward and brilliant, but you remain centered in this heartbeat moment of inward fall. The star has just experienced the fastest structural change of its entire life. You let yourself feel the contrast. For millions of years, fusion and gravity negotiated gently. In 1 second, gravity alone rewrote the core. Time is not uniform in stories of matter. The newly formed central object, whether it will become a neutron star or continue collapsing toward a black hole, depends on mass. If the remaining core mass after the coming blast is below a certain threshold, neutron pressure can hold it up. If above, even neutron matter cannot resist forever. Collapse will continue later. You do not decide the outcome yet. You simply witness the conditions forming. Around you, the inner regions are still in violent motion, not chaotic in law, but extreme in speed. Infalling layers crash into the stiffened neutron core boundary, adding to the pressure, adding to the rebound energy. Temperatures spike into the billions of degrees. Nuclear reactions flash briefly in passing zones, like sparks in a storm. Yet in your experience of it, slowed, narrated, held, it feels like a deep inhale. Everything moving inward. Everything converging. You realize that collapse is not the opposite of creation here, it is part of the creative sequence. Without this inward rush, the elements beyond iron would not be widely distributed. Without this compression, the next structure would not form. Endings in stars are engines of beginnings elsewhere. Still, you honor the gravity of the moment. A core that held itself up for ages has lost that ability. Support failed not from weakness, but from physics, from reaching the natural limit of useful fuel and effective pressure. No tragedy. Just boundary. You drift just above the newborn neutron core, unimaginably dense, spinning faster now due to conservation of angular momentum, like a skater pulling in their arms. Magnetic fields intensify. Rotation quickens. Properties transform under compression. The shock wave, newly strengthened, is preparing to move outward through the overlying layers. When it succeeds, the star's outer regions will be thrown into space in a radiant catastrophe of light and matter. But that is the next breath, the exhale after this inhale. For now, you stay with the inwardness. The surrender. The rewrite of structure at the deepest level. And as gravity completes its sudden victory at the center, and the compressed heart pushes back for the first time, you feel that the next moment will not move inward at all, it will move outward in a brilliance that changes everything around it. You remain suspended in the moment just after the great inward fall, close to the newborn, impossibly dense core. Everything that could collapse has collapsed. Everything that could compress has compressed. Gravity has drawn its deepest breath, and now, at last, the star exhales. The outward shock wave, strengthened by the rebound of the core and the subtle heating from countless streaming neutrinos, begins its climb through the overlying layers. It is not fire in the ordinary sense. It is a traveling wall of pressure and heat, a moving boundary where conditions change violently and all at once. You sense it as a rising front, like a tide made of force. Above it lie the stacked shells of the former star, silicon, oxygen, carbon, helium, hydrogen, each layer still falling inward from the earlier collapse. The shock meets this inward rain and turns it around. Infall becomes outflow. Downward becomes outward. Direction itself reverses. The collision is not quiet, but in your slowed perception it feels majestic rather than loud, like watching a storm cloud bloom in silence. Temperatures behind the shock surge into extraordinary ranges. Atomic nuclei collide and transform in rapid chains of reactions. This is where many of the universe's heaviest elements are assembled: gold, uranium, and others built in seconds from conditions too extreme for long, steady burning. You picture a forge that only opens for a heartbeat. Nuclear reactions here are driven not by patience, but by intensity. Neutrons flood the region. Nuclei capture them rapidly, then rearrange through radioactive steps into new identities. The periodic table grows branches in this brief chaos. Complexity is minted in the flash. You let that settle gently. The rarest materials in worlds and bodies are born in moments like this. The shock continues outward, gaining volume as it travels into lower density layers. More and more mass is caught in its motion. The star's envelope cannot absorb the blow. It lifts, accelerates, and begins to tear free. Gravity, once the unquestioned ruler here, is suddenly overruled in the outer regions by explosive outward energy. The surface, once a distant, glowing sphere, now surges away like mist driven by a powerful wind. Light production rises with astonishing speed. Photons that were once trapped for long wandering journeys now find expanding space and thinning matter ahead of them. Radiation escapes in a growing flood. Brightness multiplies again and again. For a short time, this single star can outshine an entire galaxy of ordinary stars. You watch the illumination expand, not as a stabbing glare, but as a blooming sphere. A flower of light opening in the dark. This is the supernova, not a burning up, but a blowing apart. The word suggests novelty, and that fits. It is a new brightness made from an old structure coming undone. The star is not erased, it is redistributed. Shell after shell is driven outward at thousands of kilometers per second. Waves form within waves, instabilities, ripples, mixing fronts. Heavier elements from deeper layers punch outward. Lighter elements from higher layers are swept along. The once neatly layered star becomes a turbulent cloud of enriched debris. You drift through the expanding ejecta and see glowing filaments forming long strands and knots shaped by turbulence and magnetic fields. density variations grow into structure. Even in explosion, patterns appear. Energy continues to pour from radioactive decay of newly formed unstable isotopes. Nickel decays into cobalt, cobalt into iron, releasing gamma rays that help keep the expanding cloud luminous for weeks and months. The afterglow has its own power source, a fading echo of nuclear rearrangement. You feel how generous the event is. Nothing is kept. Everything is given outward. Before this moment, the heavy elements were locked deep inside the star, unreachable to the wider galaxy. Now they are free, mixed into interstellar space, ready to become parts of future clouds, future stars, future planets, future living chemistry. Bones, blood, soil, circuitry, all will one day borrow from such debris. You do not rush that thought. You let it be warm. You are connected to explosions you never saw. The expanding cloud cools as it grows, but shock fronts continue to glow where fast-moving material plows into slower gas around the star. Light is produced not only from within, but from collision with the surrounding medium. The star's last act shapes its neighborhood physically, chemically, and dynamically. Space nearby is no longer quiet. It is stirred, enriched, awakened. At the center, hidden behind the brilliance, the compact remnant remains, the collapsed core you visited before. A neutron star, if the mass is modest enough. Or, if the mass is greater, an object that will continue collapsing beyond even neutron resistance. You do not open that door yet. You simply acknowledge the presence of a surviving heart. Explosion does not always mean disappearance of the center. Sometimes it means exposure. The outward moving debris carries angular momentum, magnetic field lines, and embedded radiation. It pushes on nearby clouds, compressing them slightly. In some cases, this compression will help trigger new star formation elsewhere. One ending becomes another beginning through pressure alone. You like this symmetry, collapse leading to explosion, explosion leading to collapse somewhere else. The universe recycles motion. Brightness reaches its peak and then, slowly, begins to decline. Not suddenly, never suddenly, but gradually, as expansion spreads energy across a larger and larger volume. The glowing cloud grows more transparent with time. What was once a blinding sphere becomes a vast, delicate nebula. You drift at its edge and look back. Color varies by element and temperature: reds from hydrogen, greens from oxygen, blues from hotter regions. It resembles a painted veil suspended in zero gravity. Violence translated into art. You understand now that this is not merely an ending event. It is a distribution event. A delivery system for complexity. Without these expulsions, the universe would remain mostly hydrogen and helium, simple, clean, limited. With them, chemistry gains richness. Possibility multiplies. The star's long life of balance and its brief moment of collapse both serve this final generosity. You let the light wash past you in widening rings. Motion continues outward, but urgency is gone. The decisive moment has passed. Now comes expansion, cooling, mixing, the long settling after the shout. And as the glowing debris spreads thinner across space, and the bright core remnant waits unseen at the center, you feel your attention gently drawn inward again toward the dense survivor, wondering what kind of gravity can remain after a star has already given everything else away. You approach the compact remnant left at the heart of the exploded star. The supernova's brilliance fades behind you, leaving a quiet emptiness that is almost eerie. Here, near the surviving core, the universe feels different, subtle, yet fundamentally altered. Forces that once seemed gentle and familiar now press in with a gravity beyond ordinary comprehension. This is the threshold, the boundary where outward motion, however fast, can no longer overcome inward pull. Not slowly, not gradually, but with an absolute certainty. Beyond this invisible line, nothing returns. Not matter, not light, not even the quickest photon you can imagine. You imagine standing on the edge of a vast cliff where the ground beneath you curves inward, where every step toward the void is toward a center so deep it draws not just your weight, but your possibility itself. Gravity here is immense. The remnant core, the neutron star or black hole seed, is small in volume, yet its mass is enormous. The density is beyond imagining. A teaspoonful would outweigh mountains, planets, cities. You do not approach closely. The pull is strong enough to alter your path with each heartbeat, each breath, each intention. Light, too, behaves differently here. Photons that venture too close bend along curved paths. Some escape. Others circle, trapped by the curvature of space-time. The boundary is not a barrier of bricks, but a bending of reality itself, a line where the fabric of space and time folds upon itself. You feel your mind stretching to comprehend the sensation, yet it remains only partially accessible. You are at the edge of knowing. Around you, space feels softened, strange. Distances do not act as they did before. A small step seems to carry more consequence. Time behaves differently, slower here, or perhaps stretched, a phenomenon you perceive only in subtle shifts of rhythm. The world you knew before the core's collapse seems distant, almost dreamlike. You reflect on the paradox. This is both simple and profound. Simple in the sense that gravity is only following its own rules. Profound because those rules create a realm where intuition fails. The threshold is absolute, yet unseen, definitive, yet intangible. You think of the outer layers that once expanded in the supernova. They are gone from this immediate vicinity, dispersed across space. And yet, they exist because of this core. Even in its invisibility, the remnant shapes everything around it. Its influence extends far beyond the event horizon. The boundary does not mark emptiness, only limitation. You notice the curvature of paths near the horizon. Matter falling inward seems to slow, at least from your perspective, stretching time as it approaches the line. From the inside, the collapse seems sudden and inevitable. Different observers perceive different flows of time. This is relativity made tangible. You ponder the edge of vision. What happens beyond this horizon is unknowable, in principle. You cannot trace back trajectories, cannot shine light inward. Yet physics allows you to predict effects outside, the mass, the gravity, the tidal influences, the rotation. You have knowledge at the margin, even when full sight is impossible. The concept of the singularity, the point of infinite density theorized to lie at the center, is more than a number. It is the end point of compression, the place where known physics reaches its boundary. You sense it as an idea more than a location. You feel its presence in the way spacetime curves, in the inevitability of inward pull. And yet, it is not frightening. There is calm here, a solemnity. Forces act as they must. Change happens without sentiment. You rest in observation, allowing awareness to stretch and bend around the horizon, to linger at the edge of certainty. You sense that this threshold also marks possibility. Outside, energy still moves, stars still form, matter still circulates. The black hole is not an end, but a pivot. It organizes motion, shapes trajectories, and influences the cosmos in subtle and profound ways. You watch distant light bend near the remnant, a slight warp in space's fabric, signaling its presence even if it cannot be fully entered. You perceive that boundaries can be absolute without being violent, a line that defines structure rather than destruction. Gravity is both law and architect here. Time continues, gentle yet relentless. The supernova fades further into history, and the remnants of its expelled elements drift into the galaxy. Carbon, oxygen, iron, the building blocks of worlds, float freely, carrying the memory of the star's life. Creation and destruction are intertwined. You hover at the edge of the threshold, sensing the pull, the curvature, the stretching of time, and the impossibility of returning past this line. And as you linger there, on the precipice between what can be known and what remains hidden, you feel the universe opening wider, hinting at structures beyond observation, connections beyond comprehension, and mysteries that call for the next journey. You drift closer to the boundary of the black hole remnant, hovering near the event horizon without crossing it. Here, the universe behaves in ways that challenge perception. Space and time themselves bend, warp, and fold. The familiar geometry of straight lines and predictable motions dissolves into curves and horizons. You feel that reality is no longer something you can fully measure with eyes or instruments. It is something you must sense, imagine, and calculate. Even though you cannot peer inside, science allows you to know more than intuition alone. Equations, carefully written over decades, become your guide. Einstein's field equations describe the curvature of space-time, mapping the invisible contours of gravity's extreme influence. They speak in symbols, yet you can feel their meaning. Mass tells space how to curve, space tells matter how to move. In the presence of a black hole, this relationship becomes absolute, and the contours tighten until light itself cannot escape. You picture the singularity at the center, a point where density approaches infinity, where known laws of physics cease to function as expected. It is not an object you can see, it is a concept, a boundary of understanding, a knot in the fabric of space-time. You feel the tension of this knot, its pull on surrounding dimensions, its potential to influence the galaxy without ever being visible. The event horizon acts like a shoreline at the edge of a vast ocean you cannot swim across. Beyond it lies an interior that remains unknowable, not because of lack of curiosity, but because physical law forbids direct observation. You can infer its effects, measure its influence, and predict how it shapes its surroundings. The darkness is full of information, yet inaccessible. You reflect on the paradox, even in the absence of direct knowledge, the black hole shapes everything else. Matter orbits, light bends, galaxies form spirals around it. Motion itself carries the signature of its presence. You sense that absence is active, a reminder that invisibility does not equal insignificance. Time behaves differently near this threshold. To a distant observer, infalling matter appears to slow as it approaches the event horizon, stretching into eternity. Yet for the matter itself, time flows normally. Two perspectives, each correct in its own frame. You feel the relativity of experience here. the subjective nature of even fundamental processes, and how observation is entwined with context. Inside the black hole, space and time swap roles in a sense. Radial distance becomes time-like, directing inevitable motion toward the singularity. Escape is impossible, trajectories are predetermined by the curvature of space-time. You sense inevitability here, not as fate imposed by consciousness, but as physics operating with perfect logic. Despite all this, you notice that science is not powerless. Observation of orbiting stars, gravitational lensing, and X-ray emissions allows indirect exploration. You can see the black hole by its influence, though never its interior. Measurement becomes a form of intimate storytelling, a way to know what cannot be touched. Knowledge grows not by crossing boundaries, but by understanding their effects. You feel humility in this endeavor. No equations, no telescopes, no matter how precise, can reveal the singularity itself. Curiosity meets its limit, and in that recognition, understanding deepens. The universe offers insight, yet reminds you of its vastness and mystery. Even darkness is a medium of information. Gravitational waves ripple outward when black holes collide, whispering secrets across the cosmos. Hawking radiation, subtle, quantum, slow, suggests that even these extremes interact with the rest of the universe. Nothing is completely cut off, interactions may be rare, but they exist. You linger in this liminal space, sensing both the profound absence and the subtle presence. The black hole is no void, but a region where physics plays its most extreme game. It shapes, organizes, and dictates motion around it. The singularity may remain hidden, but its consequences ripple outward, and through them, understanding can emerge. You feel that learning here is a meditation. Each fact, each observation, each inference is a gentle extension of consciousness into the unknown. The edge of understanding is not a wall to fear, but a horizon to approach slowly, with patience, wonder, and care. And as you hover on the precipice of darkness, contemplating the singularity, the curves of space-time, and the whispers of equations beyond direct sight, you sense that the next step will not be deeper inward, but outward toward the ways these objects shape the galaxy, organize matter, and connect the cosmos in patterns both hidden and visible. You pull back from the edge of darkness, leaving the event horizon behind, and allow your gaze to expand across space. The black hole you visited is no longer an isolated curiosity, it is a center of organization, a gravitational anchor around which immense systems revolve. You begin to perceive galaxies not as random gatherings of stars, but as intricate dances choreographed by unseen, powerful influences. The stars swirl in elliptical or spiral paths, each orbit subtly tuned to the mass and position of the central black hole. Gravity reaches outward, not as a blunt force, but as a guiding presence, shaping trajectories over millions of years. You notice that motion around this invisible core is orderly, like beads strung on invisible threads. The largest forces often create the most elegant patterns. You imagine the galactic core as a hidden conductor. Stars, gas clouds, dust, and dark matter respond to its pull with a rhythm that is slow yet absolute. Spiral arms wind gracefully outward, tracing the flow of angular momentum conserved over eons. Even the seemingly chaotic motions of interstellar clouds contribute to the overall stability of the system. Turbulence and gravity coexist, each amplifying the other, forming a structure that is alive in its slow, steady way. Black holes regulate more than motion. They influence the birth and death of stars. Material accreting onto the central object can generate jets, streams of plasma that shoot out perpendicular to the galactic plane at near light speed. These jets stir interstellar gas, compress some regions to trigger star formation, and evacuate others, preventing runaway collapse. In this way, extremes help maintain balance across the galaxy. You float past swirling arms, watching clouds of hydrogen and dust compress and ignite, forming new stars. You recognize that each stellar nursery owes its existence to forces that cannot be seen, yet whose effects are profound. The black hole, though invisible, has orchestrated these outcomes simply through the curvature of space and the momentum of infalling matter. Creation and destruction, order and chaos, coexist in a delicate equilibrium. Even light, as it travels through the gravitational wells near the core, follows curved paths. You see arcs of distorted starlight, gravitational lensing revealing the presence of mass that cannot be touched, yet whose effects are undeniable. Through bending light, you perceive connections between objects that seem separate but are intimately linked by the geometry of space-time. You sense that galaxies themselves are shaped by extremes. The densest regions, the most massive objects, the most energetic events all act as architects, silently organizing the cosmos. Yet in their influence lies not only control but balance. The outward pressure of radiation, the spinning motion of stars, the gravitational tug of neighbors, each component participates in a complex negotiation, maintaining structures that span tens of thousands of light years. As you drift between arms of stars and glowing nebulae, you realize that the black hole's influence is subtle, continuous, and cumulative. It does not need to reach out consciously. Its presence defines the shape and motion of matter over time. Without it, or with a slightly different mass, the galaxy might spiral differently, or even lose its cohesion. Presence is power, even when unseen. You notice smaller black holes scattered across the galaxy. Each has its own local influence, shaping nearby star clusters and stellar orbits. The principle repeats at multiple scales. Gravity organizes, structures emerge, interactions propagate. You feel a sense of rhythm in this scaling, as if the universe itself hums with orchestrated tension, from stellar cores to galactic centers. Even supernova remnants, expelled from stars like the one you visited, are guided by these gravitational patterns. Their motion, energy dissipation, and eventual assimilation into new star-forming regions are all influenced by the central mass. The feedback between stellar deaths and black hole pull ensures cycles of creation continue. You sense the interconnectedness of everything. One object's collapse shapes orbits hundreds of light years away. One explosion seeds chemical complexity in clouds that will eventually form planets. The extremes, dense, dark, powerful, are not destructive anomalies but facilitators of cosmic balance. Motion slows and stretches in your perception as you let the galaxy reveal its patterns. Spiral arms swirl gently. Star clusters orbit in measured arcs. Nebulae expand and dissipate. The black hole at the center hums invisibly, its gravity an unseen metronome, its presence felt through the choreography of all surrounding matter. And as you drift through this vast, interconnected structure, you sense that the universe is not merely a collection of isolated objects. It is a network of influence, exchange, and balance, where even the densest, darkest singularities contribute to life, motion, and the ongoing creation of cosmic harmony. You leave the galactic core slowly, carrying with you the understanding that gravity at extremes is not just a force of pull, but a force of organization, a sculptor shaping the canvas of stars, nebulae, and dust. And as you pull further outward, toward the quiet stretches of intergalactic space, you wonder about the long-term fates of these structures, and how even the densest darkness eventually meets time's slow hand. You pull farther back from the galactic spiral, giving yourself space to reflect on the black hole that shaped it. From this distance, it is no longer a looming, immediate force but a quiet presence, still immense, still dense, yet part of a larger rhythm. You notice the subtle ways the universe whispers its secrets about these objects, not through sudden flashes or visible motions, but through gentle, almost imperceptible phenomena that reveal their true nature. One of these phenomena is Hawking radiation. Though the black hole appears absolute, quantum mechanics allows tiny fluctuations at its edge. Particle-antiparticle pairs constantly form and annihilate near the event horizon. Occasionally, one particle escapes while the other falls in. Over unimaginable spans of time, this tiny leakage carries away energy. The black hole, once seemingly eternal, slowly diminishes. You imagine the process as a candle burning in reverse. Instead of light being created from wax, the darkness itself loses mass, imperceptibly, steadily. It is a gentle unraveling, a patient giving back to the universe. The act is slow beyond human comprehension, yet inevitable, a reminder that permanence is an illusion, even for the most extreme objects. You reflect on the cycles of matter and energy. Stars are born, they burn, they collapse, and they explode. Black holes form from the densest cores, shape galaxies, and eventually fade. Each stage, no matter how extreme or improbable, participates in the broader flow of the cosmos. Energy is never destroyed, only transformed, redistributed, and delayed. The universe is a patient artist, moving slowly over timescales that dwarf imagination. Even as the black hole evaporates, its presence lingers in other forms. Gravitational influence remains for millennia, organizing orbits, shaping paths, sculpting galaxies. Material expelled in supernovae continues its journey, forming new stars, planets, and perhaps eventually, life. Every act of collapse, every release of energy, contributes to the cosmic balance. You sense that endings and beginnings are inseparable, one folded into the other like the curves of spacetime itself. You notice the stillness of intergalactic space. Though stars and galaxies spin, collide, and expand, the vast distances between them are calm. The slow fate of a black hole echoes this serenity, a long, subtle exhalation after epochs of compression and concentration. It is a quiet lesson in patience, reminding you that even the most concentrated forces eventually relent, and that the universe moves at its own unhurried pace. Time stretches infinitely here. You imagine a black hole shrinking imperceptibly, atom by atom, over trillions of years. The cosmos continues around it, indifferent yet coherent, with stars forming, burning, and dying, and matter moving through cycles of energy and transformation. You feel a connection to this vast, slow rhythm, as if your own thoughts are part of the cosmic pulse. You consider that even darkness carries potential. The energy once trapped in the black hole gradually returns to the universe, participating in new structures, new motion, and perhaps new creation. Nothing is ever wasted, not even what seems irretrievably lost. The act of giving, of gradual release, becomes a kind of quiet immortality. from your vantage, the black hole is no longer a finality. It is a participant in ongoing processes, a teacher of time, patience, and transformation. You sense that all extremes, from the densest core to the faintest photon, contribute to the balance of the cosmos. The universe is never static, never truly at rest. Motion, change, and influence continue quietly, weaving through vast distances and deep time. You allow your attention to soften, following the gentle ebb of radiation and gravity, observing the slow fade of absolute density. The darkness that once seemed impenetrable now feels like a whisper, a suggestion rather than a command, a presence that slowly yields back to the larger cosmic web. And as you drift in this quiet, expansive space, you feel a sense of completion and continuity. The life of stars, the collapse of cores, the shaping of galaxies, the patient evaporation of black holes, all are part of a seamless, infinite process. You rest with the universe, breathing slowly, letting its rhythms lull your mind, knowing that even the deepest darkness eventually releases its hold, returning to the ever-moving, ever-giving cosmos.